All right, we are nearing the home stretch here. I said earlier at the beginning that that sample means, if we want to know why they're different, what is the most likely reason why X bar 1 and X bar 2 are different, we can actually use confidence intervals. We can use a confidence interval to tell us whether those means are different, probably because of sampling error alone, or maybe they're different because of sampling error plus something else. We're never going to be able to erase sampling error unless we don't sample, right? If we test the whole population, we don't have sampling error. But as soon as we begin to sample, we know we're going to have sampling error. So the question becomes, if we see a difference, for example, between a dim screen, a medium brightness, and a high bright screen, right? High intensity brightness. If we see a difference between those three means, can we just chalk that up to sampling error? Or is there sampling error, but there's something also on top of that? And then we would argue, oh, it must have been the screen brightness. All right. So here's how this is going to work. Okay. What we're going to do is we're going to calculate either the 95% confidence interval around both means. So we're going to calculate 95% confidence interval around X bar 1 and X bar 2. And we're going to see if those confidence intervals overlap each other. Or we could use the 99%. So we calculate the 99% confidence interval here, the 99% confidence interval there, and see if they overlap. Please note, you would not calculate the 95 confidence interval here, percent confidence interval here, and the 99 there. Okay, you got to keep apples to apples, oranges to oranges. So they are both 95 or they're both 99. There's never a mix. The other thing I want you to note here is that we are, hold on a second, we are not going to be able to use this 68% confidence interval to make that, kind of at least tentative decision of whether the means are different because of sampling error or sampling error plus something else. If we want to use confidence intervals to answer that question, it has to be the 95 or the 99% confidence interval. All right, so let's look at what we mean confidence intervals overlapping and non-overlapping. All right, so here's your mean for, let's just pretend we have two screens, dim and bright, okay? So right smack in the middle, that would be 50. So whatever 50 represents the reading speed, I guess. So 50 is your X bar, and the interval that we drew around it is from 40 to 60, right? And let's pretend that this is the 95% confidence interval, but, maybe it's the 99. It doesn't matter. Okay, in this particular example, it doesn't matter. So what we're saying, if it's 95, we're saying, look, 95 times out of 100, we've drawn this correctly, and mu is somewhere here. All right, now let's say that this is the mean for the bright screen. We draw a confidence interval around it. And let's say that it turns out that the upper and lower limits are 50 to 70. Now the question is, are there values in this range that overlap with values in this range? In other words, are there shared values, shared numbers? And the answer is yes, because look, here, what do they have in common? The numbers 50 to 60. 50 to 60 occur in this interval, and 50 to 60 occur in this interval. So you see how they have shared values? That means they overlap. And when that happens, your safest bet is to say that the most likely reason why these two means are different is probably because of sampling error alone. All right? So that's something that you have to know. Now I'll explain why. You're saying that mu is somewhere in this interval, right? you're saying 95 times out of 100 mu is here. And you're also saying 95 times out of 100, the true mean for this x bar is somewhere in this interval. Well, does that not mean that you can have a mu here that equals a mu there? See how there's overlap? So these two mu's might actually be the same. All right, in which case these x bars are probably, they probably belong to the same distribution. They are not two separate distributions. They probably belong to the same distribution. The only reason why they're different is because of sampling error. Here's an example where the confidence intervals do not overlap. So let's say you draw an interval around the dim screen and the bright screen. Here the confidence interval goes from 50 to 60. Here it goes from 70 to 90. All right, you see how there's no values in common? This one stops at 60 and this one picks up at 70, so there's no shared values. When that happens, the confidence intervals, again, they don't overlap. Then you would want to say, well, then it's probably the case that the most likely reason why these two means are different. Okay, so we have to explain why these are different. We're going to say it's probably sampling error plus something else. Something else is going on. All right, so essentially what we're saying is that the true mean mu for this dim screen is probably different from the true mean mu for the bright screen. These are different distributions. And, we could be wrong. For example, we could be wrong. What if mu for the dim screen is out here? And what if the true mean mu for the bright screen is way over here? Then these two means could be the same, right? It could be the same mu, but probably not. We go with the odds. Odds are mu for this distribution is here. Mu for this distribution is here. And they do not equal each other. There's no overlap.